Hello, dear friends. In this video, we are going to see about what is chatbot, and especially we are going to also discuss about RAG and how chatbot is related to RAG, and we are going to see a simple example also how to make a RAG, which may be useful for the chatbot. So let's first discuss what is actually a chatbot. Chatbot can be a software application that allow user to communicate using natural language processing. We all might have an experience of chatting or conversing with a chatbot. So here, generally in traditional chatbots, like we can say it is like predefined rules. Maybe many times we might have come across some like customer related chatbot customer query. So when we start that, when we use the chatbot, so it will be asking if you want to continue in English, then click one. And if you want this service, then click two, something like that. So in traditional chatbots, we have all the things already predefined. Questions will be there, answer will be there. So based on that, it will be working. But here we are going to discuss about the chatbot like what actually it is going to do is it is going to understand our natural language, our speech and our text, and it is going to understand it, and then it is going to respond to us back in the natural language itself. Natural language means the language which we speak. So there is a difference between a machine speaks and a human speaks, right? We have our own way of conversing with our friends or with what. So in the natural language itself, it is going to communicate with us. So that is what the chatbot here we are going to discuss about. So as I told you, the traditional chatbots will always follow the predefined rules. It has only fixed question and an answer. So as I told, like many times whenever we ask for any queries or any service in this kind of traditional chatbot, it will be asking us to follow some rules. Accordingly, it will be responding back to us. But in AI based chatbots, it will understand our language in the way which we speak itself, and then it will be dynamically and giving us the answer according to that situation. And then it will be using a large language model for us to provide the service. So the example for this are ChatGPT and other kind of chatbots. So as we know that if you use only the traditional LLM chatbots, okay, so now you have understood what is chatbot and how it is different from the traditional chatbot. So, in the traditional chatbot, where we are using LLM to help us to respond, get the answer back in the natural language itself. But there is a problem in this traditional LLM chatbot is hallucination. So already in the previous in my playlist, you might have come across a video with hallucination. So the problem is it'll even in many of us may be familiar with working with ChatGPT and other LLMs like Claude and all. Sometimes we might have come across like if you ask some question, it may be giving the answer, but it may not be correct. Factual answer may not be correct because we know that this kind of LLMs are pre-trained with some data, and so that and also it is every time it is going to predict one token after token. So it may be giving us an answer, but it will not go and check, is it real, is it the fact is it a fact one or not. It won't check it. So there is a knowledge cutoff limitation also. So if you ask a domain specific question, it doesn't have the answer. It may be giving a general answer. So and also there is a limitation. It doesn't have an access to a private data, maybe a particular organization. It may not be getting the private access to the data of that particular organization. So if we ask a question related to that, then it doesn't able to answer us. So these are all the problems in traditional LLM chatbots. So so what we can do is chatbot. So chatbot, when we use LLMs in model, it uses LLM. And as I told you, it is always predicting the next token. It doesn't store any answer, but based on the pre-trained model on which it is trained, no, the pre-trained data, if you ask any question, it will try to predict the next token and it will answer us. That's what actually happened. So it is not going to search for an answer. Instead, it's going to generate the response based on the language pattern it has already learned. That is during the pre-training, what the model has learned. Based on that, it does the next predictions. But the problem, as I told you, it doesn't have a private data access. It doesn't have no domain specific answer. It doesn't have like uh, like a correct answer to a particular, for example, if I ask a medical question, it may not have that particular answer for that. And also hallucination may be another problem. To avoid all this thing, we are going to integrate RAG with the LLM. So what does RAG specify? It's a retrieval augmented generation. So what actually it is retrieval means it is going to use some external knowledge. So the knowledge may be an external PDF or a website, whatever database or anything, any document. It is going to refer the external knowledge and going to retrieve the correct answer and the query, as well as this answer or query means the question which we asked, that query, and the answer which it got from the particular external knowledge, both will be sent to the LLM. Then the LLM, so that is what augmenting. So it is going to augment the external data which it retrieve and augment, and then the LLM will generate the human-like answer. So that is what happens in the RAG. So specifically, it is going to retrieve the external document, augment it with the query and give to the LLM, and the LLM will be generating as the answer. So that is what the basic thing happens in the RAG. So what happened means, so when I ask a particular question, a domain-specific question, then the question will be given to the external document. If it is a medical data, so it will be going and finding the data. It is grounded externally. Just go and search the particular data, come back and augment it with the LLM and get us the answer. So that is what the simple working of a RAG. So what is the workflow for it is means, so whenever I'm going to show you that, so actually what happens, I'll show the diagram so that you'll understand it very clearly. This is what the workflow. So what happens in the RAG, for example, you consider it's a medical data. For a particular disease or for a particular organization data, whatever it may be. So that is our knowledge base. So for example, if all the medical related data means that will be there in the knowledge base. So those data will be splitted into small parts. So it is not together given inside as an input. Instead, this complete data is splitted into small size that we call it as chunk, that we can specify what should be the size of the chunk and how many chunks should be there. So that we can give us an input. So we have a knowledge base. It can be a PDF or it can be any other website or it can be a database or whatever it may be. So those data will be now splitted into small data chunk. And then to this data chunk, embedding will be happening. What does embedding means? Converting the text into a numerical representation that is in the form of vector. This process is called embedding. And that complete knowledge base is now stored in a numerical format, that is in the vector format inside this embedding model. So for that, we have so many models to do this embedding, which means converting the text into numerical format. So that will be here. And now the knowledge base is ready. Now the user may be asking some question related to medical field. So that is our query. So what happened here is this query will also be converted. The embedding will happen here also. The query which I may be asking will also be converted to a numerical representation in the form of a vector, and that will be stored in the embedding model. So here it can be stored in a vector database. In the next video, we will be discussing about what is vector library and vector database and all these things. So here, this data will be stored here. And now when a user is asking a query, this query is also in the numerical format. So what happened? It will go and find the most similar, it find the similar answer which is related to this query, and it will get the answer back. And so here, that is what the vector database embedding will also be stored in the vector database. And when I ask a question, so it will find the similar data and retrieve the document back. And this retrieved document will be given to the LLM along with the query. So that's important, along with the query. And now the LLM have the answer as well as the query, right? So now it will answer us in a human-like pattern. So here I'll show a small website where it is showing like how it will be doing this. So you can see here. Um, okay, wait a minute. So, so here I am asking something related to artificial. So whichever word, so we have all the vectors stored together. So whichever is so close to each other, that will be identified. So here I can say artificial. So whatever thing is related to artificial, or we can use any of the distance-based algorithm or any like similarity checking algorithm like cosine similarity or some algorithm can be used here, and then it will be finding the answer, and then it will be giving us the answer. So that's what happened in the vector database. So it finds the query will be compared with the most similar data, and it will be getting the retrieved data given to the LLM and will be getting the answer. So now let us discuss about the RAG. So now you hope you got what is RAG is. So now we are going to discuss about the RAG in the chatbot. So chatbot is powered by the LLM, are very good, not naturally, but it will be mostly lacking the domain specific knowledge. So only integrating LLM with a chatbot may not be always fruitful because it may not have the domain specific knowledge. To avoid this only, because it may not be giving the factual answer. It gives some answer, but may not be actually factual. So, or a specialized answer may not be given. So, to avoid this only, we are going to integrate this RAG to avoid the limitation. And then the RAG, since the RAG is already grounded to the external information, maybe a database or a PDF or a document or a website, whatever it may be. So it will be giving a more domain specific answer. So it's more, it will be giving more relevant answer. So rather than having only LLM, so RAG will be giving a clear answer. So instead of relying only on the model's pre-trained knowledge, so the chatbot will be really getting the most relevant information, and then the information will be more accurate and informative as well. So now you might have understood what is the process behind this RAG. So the RAG, what is the important process? So it is going to convert everything, the knowledge base and the query in the numerical format stored in the vector database. So, and the query is also compared with the document, so to which it is, so by which it will be finding the more relevant answer, and then it is given to the LLM, and the LLM will be giving us the answer in a human format, human-like format. So that is what the step. And so the basic things in this RAG is retrieval. So LLM alone does not have an access to the private data, as I told you, PDF or private organization data may not be available. So to make the chatbot answer to a particular specific document, we can use retrieval. So using retrieval, you can able to get the grounded external resources data, and then we can able to so what is retrieval means? Finding the relevant information from the stored document before generating the answer. Instead of generating answer only from the LLM from its already trained data, I'm going to get the most relevant answer from the grounded document and give that document to the LLM. So LLM now have the answer, no exact answer, domain specific answer without hallucination. Then it can able to give us the answer in a human-like format. So now let us see an example for this so that you will understand very well. So if I'm making a chatbot without retrieval, which means without RAG means sometimes it may hallucinate. But if I use a retrieval augmented generation, right? That is what RAG is. So it will get the actual document, get the actual answer, and it will give you the accurate result. So let us see a simple example. so that you will clearly understand actually what is happening. So here you can see, you can see here, we are going to see an example of how the similarity search will be happening. A small mini format of RAG, let us discuss. Okay. So first what happened is, as I told you in the PPT, retrieval RAG, which means we are first going to see the retrieval part of the RAG. So what happens in the retrieval part? First, the embedding will be happening. So if you see, if you remember this diagram, so first it will be doing the retrieval, right? So it has to retrieve the data. So then it will convert the text into vectors using some transformer models. So it will do the embedding, and so then the text will be converted to vectors. Then it will be finding the similarity check. Maybe cosine similarity may be used, or any other distance-based algorithm can also be used. After finding the similar answer, the retrieval will be happening. That is, a more relevant answer will be taken. So let's see an example on it. So here, from the Python library, we are going to take the all necessary packages which we need. So I want to find the cosine similarity. No, for that I'm going to use the cosine similarity, and I want to also convert my data into a embedding format. So for that I have a text transformer. Okay, so I have imported S. Now what I am going to use is, I am from the text transformer, I am going to use this model all mini LM L6V2 for doing the embedding. Embedding means what? Converting our text to a vector format. That process is called embedding. So for that, I am going to use this model. So now this model is available in this object or a variable. Now, if you see in this PPT, the model is ready to do the text converted to numerical form. What is the next thing I want? I want a knowledge base, right? So here is user defined. I have a small knowledge base. So where I have some 3 statements, this I'm going to use as a knowledge base. So I told the knowledge base can be a PDF or a database or any other external resources. So here we are going to use this as our knowledge base. So I have given Python as a programming language. Machine learning is a part of AI. Grok provide fast LLM interface. So these things are my documents. So now what I have to do? So 2 embedding should be happening. One, the knowledge base should be converted to a numerical form and stored in the vector database. And similarly, the user query also needs to be converted. That is, embedding needs to be happen, and then that also will be stored in the vector database and find a similarity. So here, what I am going to do, this document. Now, this document is now encoded using this model. So embedding model is a variable which is attached to this transformer model, which help us to do the embedding, that is converting the text to numerical format. So using that model, I'm encoding this document. So now the embedding of my document is ready. Same way, I have to, what is the next thing? So this part is over. This is converted to a numerical format. And now the query needs to be also converted to numerical format, right? So far, this is my query. I'm asking what is AI. So this query also needs to be converted to numerical format. So again, same model is used, embedding model dot encode. What I need to encode is query. Now the document is also encoded. And in the embedding, it is also present in the form of numerical format, and also the query is also in the form of numerical format. So we have document embedding as well as a query embedding. Now I'm going to find the similarity between the both. What is the similarity I want to find? So my question is, what is AI? So according to this question is similar to which statement in my knowledge base? That's what I want to find. So for that, we are going to use cosine similarity. What should be the input? One should be the document embedding. So the document, the knowledge base should be given as an input, as well as the query should also be given as an input. So both are given to find the similarities, to find the similarity between. So this statement is matching to which one of these 3 statements that I have to find. So for that, I'm going to use, so that will be in this variable. So I'm going to say, in that, I'm going to take the maximum similarity. That is what argmax. So argmax will find the most similar one from this document, and then the answer is going to be in this retrieve document. So we are going to print it. So we can see what is AI. So which statement is more similar to this is, we know that exactly machine learning is a part of AI. So if you see in our answer, the retrieved answer we are getting is machine learning is part of AI. So it is exactly finding the correct answer. So this is how it is working. So here what we saw is the retrieval part. So how embedding is happening. So here we saw this is our model which is going to do the embedding, that is converting the text to numerical form. This is my knowledge base, and both the knowledge base as well as the query is converted to embedding. And then using cosine similarity, we are finding the similarity between these two. And the most similar one is taken and it is in the retrieve document. And we are printing this retrieve document, right? So here is the answer for that. So this is how retrieval will be happening. So now after that, what we saw is after it is doing the retrieval, it has to send the data to the LLM and the LLM will be responding to us, right? So let us see for that. So I'm going to get a LLM using Grok API key. So we know that Grok is a company where it is going to provide us the LLMs, which is available in the cloud. We can access it through the API key. So already in the previous videos, I have told how to get the API key. It's a free API key and we can store that API key here. So it is already stored here. It's sorry, what happened? So this is my key. So it is like a password, so we have to keep it safe, secure. So I'm stored here using this variable like Grok API. So that's what I have given that as input. So using this API key, I'm going to access the model called Llama 3.18V instant. So now the model is now attached to this variable LLM. So now LLM is also ready. So what is that? This part is also now ready. LLM is now ready. Now what you have to do, the data which we retrieve from this vector database should be given to the LLM, right? That's what we are going to see. So here the model is LLM and now I have the prompt. So what is the prompt says? Answer the question based. It's like a template, prompt template. We have already learned chain. So I have a template already. So it's which is stored in the variable called prompt. So it says that answer the question based on the context below. So what is retrieved document and query? We already know. So retrieved document is here. So this is what the retrieved document and this is what the query. So we are going to give the query as well as the retrieved document. With what is the retrieved document? Machine learning is part of AI. So what is AI? Machine learning is a part of AI. Both will be now given to the LLM. As I told you, the query will also be given to the LLM and also the retrieved document for this query will also be given to the LLM. So that's what happening here. So now you can see here. So the query as well as the retrieve document both are given to the LLM. So here I say LLM.invoke. What is invoke function is it will give the question and it will expect the answer from that. So this will help us to give the question and get the answer back. So the prompt, this prompt is given to this LLM and the LLM will give the response. So from the response, a lot of response will be there, including the metadata. So from that, I want only the content. So that alone is retrieved and now it is going to be print. So here you can see it's the final answer based on the given content. It say A stands for artificial intelligence. So that's how, so that is not in our document. See, document is in different form. Now LLM has responded in this format in a human-like format. As what we generally ask, it will give the relevant answer because we are getting the answer now from the LLM. So now I think this flow you might have clearly understand. And so the knowledge base as well as the query are in the numerical format. For this query, get the most relevant answer. And the query as well as the relevant answer is given to the LLM and the LLM is going to respond us back. So this is how normally a RAG is working. I hope you are clear about the working of the RAG. And so we also learned about this. So now finally we'll end with there is another one called RAG means now you have understood. So RAG is like we are going to have external ground along with the LLM. So whenever we have a query, we get the relevant information or factual information from the grounded source and we will be getting it and give to LLM and get the answer back. So we have another one called Retrieval Augmented Language Model. This is RAG. This is RALMS. That is Retrieval Augmented Language Model. So what actually happened here is during the training itself, we will be giving the most relevant information. And while generating the response, it will get the most relevant information. So combine story knowledge with external information, because since we are doing the training itself, we are going to give the most relevant domain specific information, and so that we'll be getting the relevant answer. But this RAMS, no, RALMS, that is Retrieval Augmented Language Model, is most probably used for the research purpose. So RAG is like a method you build it. So this is like a type of model. The model itself is already trained. So let's see the difference between them. So RAG is a technique or a workflow. We know what happens in the RAG just before we saw. It will be retrieving the relevant document and then pass to the LLM and then generate the answer. So that's what the RAG will be. But what happens in this RAMs means the model or the architecture itself, the retrieval will be happening because the model itself is built using some specific information. So the language model that inherently knows how the retrieval and generation will be happening, because the part of the model itself is trained based on that. So that is the difference. So here, if you see the difference, actually RAG is like a workflow or a technique. So one after other. So first embedding and then retrieve and then give to LLM. So it's like a workflow technique. But here RAGs is like a model architecture. The model itself is trained with the specific data. Flexibility is more in RAG because I can ground to any external data. But here in the RAGs, so less specific because it is pre-designed. No, during the model training itself, we have to do in that way itself. And the implementation for RAG is very easy. If you use some Python framework like LangChain, integration is very, very easy. But RAMS is complex because it's mostly used for research purpose. So we control is RAG is we can have a full control over the retrieval, but the retrieval is itself is embedding because the model is already trained based on the specific data. So we cannot just like the change or anything. So RAG is used very commonly in industry, but RAMS is less commonly used because most probably it is used for research purpose. So now we can understand that. So I said some of the limitations in LLM, those limitations are overcome by the RAGs by which it can able to provide a quality and accurate answer with the help of LLM, since it is grounded with the external resource. And we saw an example for all those things. So it reduced the hallucination by retrieving the relevant and most domain specific knowledge and reliable factual answer. So for example, if I'm asking a question for healthcare related application, so the LLM can retrieve the medical information from the trusted sources, maybe any medical literature or anything or a database. And then from the retrieved information, along with the query, the LLM will help us to give the most domain specific accurate answer. And here comes another term called vector search. So already we learned that all the input are in the form of vectors, the numerical form. That process only we call an embedding. So what is the vector search is? It's a method to find the vectors, the embedding, the numerical representation that are similar to our query. So it is like working like comparing the similarity between the embedding. So the query embedding and the knowledge base embedding will be compared. So where we can use it is commonly used in recommendation system, image search, text search, anomaly detection. In all these places, we can use this vector search. So I hope you have understood what is this chatbot means and how chatbot can compare to traditional chatbot, how our AI-based chatbot is working very fine and giving a human-like answer. So this happens because of the not only because of an LLM but also the LLM attached with RAG. And we saw an example also for that. I hope you have got it. So thank you for listening. God bless.